Oh, this worked in the first try. Great. Good evening, everyone. I'm Anurag. I work at Hurricane Electric, and we operate a global backbone in all the continents right now. And I'd be talking about misused top ASNs. So as a part of running a large network, we do see lots and lots of noise in the routing table, and this is just a quick fun talk about the misuse of AS1, 2, and 3, and the times we see them in the routing table when we don't expect them to. So before we jump into that, a quick introduction, who they are. So AS1 is with level 3 communications, that's CenturyLink now. AS2 is University of Delaware, and AS3 is MIT. So except AS1, other two are not a transit network. There are times when we see them as transit networks in the routing table and across various tools. So how are they misused? Well, a lot of people just copy-paste the sample prepend configuration. So a lot of configuration just says prepend your ASN, twice or thrice, put 1, 2, and 3. People just copy-paste and put them in the router. And if you don't believe me, I have some dumps to actually show that. People also write 1, 2, or 3 in the prepend rules. And it just happens. And there are a couple of other interesting patterns which I did not cover in this talk, but there are patterns, especially with the 4-byte ASN, where say you have ASN 1, 2, 3, 4, and someone tries to write them 4, 5 times and accidentally misses one of the digits. So suddenly you see 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 4, and then 1, 2, 3, 4, showing vague patterns. So why is it important? How exactly that impacts? Do we really need to worry about it? So that shows, one part of it is it shows unexpected relationship of the leaking ASN. So that's on the tools like one of our tools, bgp.he.net, as well as say things like stat.ripe.net. You'll just see crazy unexpected relationship. You'll see University of MIT suddenly popping up somewhere far, far away as the transit provider of some other network. It can be considered as AS hijack, and it's bad for the trusted internet as we use it. It can result in announcement getting filtered if the upstream provider or the peer of the network is filtering based on the AS paths. There is a high possibility of getting it filtered. And it can also result in broken connectivity with these networks if they don't have a default route. Whether they have a default route or not, that I don't really know, but it can always result in a scenario where if they don't have any default route, there would be just no connectivity with these actual networks. So here's the graph of AS1. This was taken around, I think, maybe three weeks ago. This is from bgp.he.net. I'm not sure if you can read it here. It seems small. But that shows it's just lots and lots of relationships. Probably you'd be able to see the list of the peers of AS1. So that's some network in Argentina, then there are a couple of networks in US. There's one network in India, then there are a couple other networks in South Africa. It clearly shows something is wrong here. So we go for this activity, fun activity of hunting for the leakers who are causing this misuse. We looked at the routing table from RIPE RIS as well as Oregon route views. So you get a reasonable picture from these dumps. This analysis was done from 2015 to 18. I did another talk in past where we did analysis up to 2015. So this was a kind of version 2 for the talk just to see if something has changed. We look for the top 3 ASNs which are appearing in the AS path, and we have a specific algorithm to call it a leak or a non-leak. I'll come to that in the next slide. We focus on the ASNs which are prepending. So we shortlist the ASNs which are prepending, and the leaks which are for less than 24 hours, we don't collect them because this is too much of data if you start with that. And possibly I think it can be done, but that just adds a hell lot of data set if you want to add it for less than 24 hours. There are multiple route collectors which do not share their images for less than that. So here's the algorithm we use: leak or legitimate. So we look for the cases where these ASNs are appearing and they have absolutely no relation with the adjacency. So if you have someone, say in South Africa or Argentina, or the cases as just came up, and they have absolutely no organization-wise relation with the AS1, we consider it as one of the reasons, possible reasons. We look for the left side in the AS path, which is the upstream provider. So if we see AS1, 2, or 3 on the left side in the AS path, that is one of the interesting cases. We also look for the cases where there is a less specific origination from a prefix and a more specific from AS1. Like this example, you see AS1 suddenly originating a prefix in /24, while the /20 equivalent for that, the superset of that, is being originated by someone else. And this someone else happens to be the adjacency for AS1. There are many cases for 1, 2, and 3 in the similar pattern, and we assume that all these are the leaks, probably misuse of the ASN. Just a quick list of some of the networks which leaked AS1, 2, and 3. Is this list of AS numbers? The interesting part here is the amount of time. So you can see some of the leakers have been doing this for as long as 4 to 5 years. You have 1460 days, the leak is still going on. I think this was the top one is the case which is still there in the routing table. Probably top 3 are still there for a while. Others were there for probably little over a year. Same thing for AS2, close to 3 years for the top one, still there, probably so now increased a little more. And for AS3, I'm not going to stay more on this slide because it's lightning talk, and I'll try to stick with that. Here's the visibility in terms of graphs. So these were the networks which were leaking AS1, 2, and 3 all combined for a really long time. So you can see some of them have been doing it for a very long time, while the other is still close to a year at least for this kind of data for top 10. Here comes the most amusing AS path you might have ever seen. This is the one of the leak which suddenly created adjacencies between AS1, AS2, AS3, AS4, and AS5. And we just found it in the dumps because we were looking at 1, 2, and 3 and suddenly noticed it's there. So someone trying to, probably AS1614, trying to prepend it, and they wrote their ASN 5 times. And after that, they just wrote 1, 2, 3, 4, and 5 and just announced it in the routing table. So just quick info on preventing such leaks. So if you are prepending, just copy paste, especially for the 4-byte ASNs. Don't start typing your ASN by hand. If you have just joined your organization and don't remember your ASN well, avoid try to generate config by using tools like BGP-Q3. That surely helps. If you're running an internet exchange, and this is one of the cool parts which is of high interest now, there are very good tools like IXP Manager and ARoute Server, using which you can generate configuration for your route server. So if you are at an exchange, you can generate config automatically and make sure that such cases never propagate beyond your route server. And most of those auto generation, besides including the prefix filter, does include the AS path filter as well, and that significantly reduces the noise. And of course, we encourage the use of RPKI. That should significantly help. It was great to hear yesterday from AT&T about it. Just sample config. If someone accidentally lands on it, this is how you should prepend. References, so Oregon route views for providing the dumps, RIPE-RIS for the dumps, our toolkit, which is bgp.he.net, and then the BGP dump tool, which is from RIPE. It works very well, although we are trying to also use the Isolario's open source tool, which is BGP scanner, which seems to be much faster than BGP dump these days. That's about it. Thank you.